Good evening, sir, and to all my fellow friends. Today we are going to present about oscilloscope function and generator. And this is my group member, and my name is Hairil bin Harun, and my matrix number is 07DE23F1051.
And my name is Danish. My matrix number is 07DE23F1045.
And this is my first batch introduction. An oscilloscope is a laboratory instrument commonly used to display and analyze the waveform of electronic signals. In effect, the device draws a graph of the instant- instantaneous signal voltage as a function of time. Function generator is basically a signal generator that produces different types of waveforms at the output. It, it has the ability to produce waveforms such as sine wave, square wave, triangular wave, sawtooth wave, etc. An adjustable frequency range is provided by the function generator, which is the range of some Hs to several 100
Hertz.
kHs. How to use oscilloscope? Step 1. Learn what an oscilloscope measure. An oscilloscope measure the voltage of an electrical current, unlike a multimeter, which only measure the RMS voltage. An oscilloscope takes multiple voltage measurement and plots them on a graph in the form of a wave pattern. This is allows you to see exactly what the voltage is doing over time. Step 2. Explore the display. The display on an oscilloscope display voltage over time in the form of a wave pattern. This allow you to see how voltage pulses over time. The horizontal axis on the display represent time usually. The time scale represented of on the display is only a few milliseconds. The vertical axis on the display reflection voltage. The waveform on the display show how the voltage rise and falls over time. The square in the grid are called division. They are used to reflection unit measurement. How much each division reflection depends on how the vertical and horizontal positioning set on the oscilloscope. Step 3. Understand the oscilloscope channel. Most oscilloscopes have between 2 to 4 channels. Each channel has a separate input and that you can connect a probe to. This allows you to measure multiple components at a time. The waveform that each probe measure is represented with a different color on the display. Step 4. Learn the learn the difference between periodic and non-periodic waves. Waves that produce a consistent pattern that does not change over time are called periodic waves. Waves that are constantly changing and do not produce a predictable pattern are called non-periodic waves. Non-periodic waves are usually caused by some external inputs such as user controls, knobs
Okay.
and button, etc. Atmospheric
Interference.
interference or something the circuit is measuring. Step 5. Know the different types of waves. There are a variety of different types of waves patterns you will see in a oscilloscope display. This correspond to the different types of electrical currents you might be measuring. Some of these waves are as follow. This is sine waveforms. Sine waveform, a sine wave consistently oscill-
Oscillates
oscillates up and down, producing smooth-looking waves that gradually rise,
increase
crease, and
and
then gradually fall. Sine waves are most commonly found when measuring
alternating
alternating
current.
current. This is square waveform and triangle waveform. Square waveform. When measuring direct current DC, the oscilloscope will display a flat line representing the voltage. Many digital and time-based
Component
components pulse on
and on
and off thousands of times a second. This produces square or
rectangle
rectangle shaped waves that rise suddenly when the current is on and then drop suddenly when the current is off. This is sometimes
referred to as
referred to as a pulse wave. Triangle waves. Triangle waves rise consistently, peak and then drop consistently, and the same rate. This produce triangle shaped waves. Waves that rise consistently and then drop off suddenly or rise suddenly and drop off consistently are called sawtooth webs. They are often found in analog to digital
common
conversion circuit, switch mode power supplies,
and
and power driver control circuit. Step 6. Understand what an oscilloscope can show you. Oscilloscope measure voltage, but there are lots of other measurements you can make with an oscilloscope. These include the following. Voltage. Voltage is the maximum amount of electrical potential between 2 points of a circuit. This is usually a circuit component and the ground. You can determine the voltage by subtracting the minimum point of a wave from the maximum point of a wave. Frequency. In addition to measuring how much voltage is in an electrical current, you can also measure the amount of time in between each wave. Wavelength. Using an oscilloscope, you can measure the length of each wave or pulse in an electrical current. Slope length. You can also use an oscilloscope to measure how long it takes each wave to rise to its peak and then drop back down again.
equally. How to use function generator. First, put power on the generator and select the desired output signal like square wave, sine wave, or triangle wave. Second, connect the output leads to an oscilloscope to visualize the output signal and set its parameters using the amplitude and frequency controls. Third, attach the output leads of the function generator to the input of the circuit you wish to test. And last, attach the output of your circuit to a meter or oscilloscope to visualize the resulting change in signal. Safety precautions for oscilloscope. First, always read the safety notice that is included in the user manual of your oscilloscope. It will contain important information about safe usage, including how to handle the device, how to connect it to power, and how to avoid electrical hazards. Avoid vibration and mechanical shock. Like most electrical equipment, an oscilloscope is a delicate instrument. If an internal fan or blower is used, make sure that it is operating. Keep ventilation, air filters clean. Third, lift the oscilloscope by the handles when transporting. Avoid picking up the oscilloscope with your hand over the front panel. If the oscilloscope slips, damage may occur to the knobs or input connectors. Preferably, use the snap-on front cover to protect the front. Connect the ground lead of the probe to a ground only. Replace batteries only with the proper type and rating specified. Recharge batteries properly for the recommended charge cycle only. Do not operate this product with covers or panels removed. Use proper fuse. Here is safety precautions for function generator. Always read the safety notice that is included in the user manual of your function generator. It will contain important information about safe usage, including how to handle the device, how to connect it to power, and how to avoid electrical hazards. Avoid using the function generator in high temperature and high pressure, humidity, strong vibration, and strong magnetic fields. Use the function generator in a relatively stable environment and provide good ventilation and cooling conditions. When the fuse blows, please correct the causes of failure. In conclusion, we learned about what is oscilloscope and function generator. Plus, we also learned how to use oscilloscope and function generator properly. Finally, we also learned some of the safety precautions when using both oscilloscope and function generator. Thank you for watching. This is the end of our presentation. Thank you. Bye.